So we are now going to talk about how to prove triangles congruent by labeling diagrams and picking a method of proof. So the first thing is, what criteria establish congruent triangles? There are 5, the first being angle side angle. So angle side angle is when two triangles have two pairs of angles and a side congruent, but the notation is angle side angle because the side has to be in between the two angles, as you're seeing in this picture. So that could happen in multiple ways. It could happen as you see it. It could also happen here where you have this bottom right angle, this side, and that angle. That would also be angle side angle. And then it could also happen with this third side with those two angles. The side has to be in between. If it's not this criteria. So anytime you have two triangles with a pair of angles with a side in between another pair of angles that are congruent, that is going to be the angle side angle criteria. The next option is angle, angle, side. So as you can see, again, two angles and a side, but this time it's saying those two angles and a side not in between them. So in this case, this would be angle, angle, side, or also this would be angle, angle, side with that criteria because it's two angles and a side not in between. Another method of criteria is side, angle, side. So again, you're understanding that the letters and the order matter now. That's two pairs of congruent sides and a pair of congruent angles. The congruent angles must be in between the two congruent sides. So basically, the two sides that make up the angle are the two congruent pairs, and then the angle that the two sides make up are your angle pair. That can happen anywhere in the triangle. So again, if it were the bottom right angle, it would be those two sides. And lastly, we have side, 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 and that's when you have three congruent sides. So that one's pretty easy to tell mostly because it's when all three sides are congruent. There's also a criteria called hypotenuse leg, and that happens in right triangles only. So anytime you see HL, that means that you have a right triangle and its hypotenuse is congruent to another right triangle's hypotenuse, and one of the leg pairs they're congruent as well. So this is what that would look like. Again, it's a right triangle, then you have a hypotenuse and a leg. It doesn't have to be the bottom leg, it could be the side leg, but that's what hypotenuse leg looks like. All right, so which criteria do not work? There's two, angle, 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 and if you read that, it kind of sounds like you're screaming at yourself, right? Because if you read angle, 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 it says, ah! So don't do that. That's going to be when you have three equal angles in two different triangles. So let's think about an equilateral triangle, for instance. We know that every equilateral triangle in the universe has three 60-degree angles, but they don't have to be the same size sides. So I could have an equilateral triangle with, side lengths of 1 and another equilateral triangle with side lengths of 5. The other one that does not establish congruence is side-side angle. Now, I want you to just think about what that would spell if we put it a different way, so never swear at yourself in geometry, people. That's a good way to remember that one doesn't work. So here is what it is. If you have two pairs of congruent sides, so that's what I showed you here. I have two sides that are red, that are kind of slanted. I have two sides that are horizontal, and then I have an angle that's dotted. So if I have two sides and an angle, and I try to make a triangle, so if I form that bottom one, I join two of the sides because it says side, side, they should be touching, and then I put the angle to the right. Okay, but I also could set it up a different way. So here's the problem. They don't give me an angle in this bottom left, so I really could put that in any direction. So when I make that other angle that's not touching, it could connect in any different area. So because there's no like hinge kind of, there's nothing making the angle in the bottom left stay rigid, that could move in any way. So that's why side-side angle doesn't work, because there's no way to ensure that it would be, in fact, a congruent triangle. So here is how we were going to start establishing this. We're going to look at these. We're going to say, hey, are they congruent? You're going to write a congruent statement, so corresponding parts, and then you're going to say the criteria. So I'm going to look at this picture, and I'm going to say, hey, there are good old vertical angles. Remember, vertical angles always are congruent, so we can go ahead, even if it's not labeled or told to us, we can always know that those are congruent. So this is going to be a yes, and the reason is, again, I'm going to check my list. I'm going to look for side, 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 angle, side, all of those good things. So here I have angle, angle, side in both circumstances. I have the O's that are congruent, the X's that are congruent, and then I have a pair of sides that are congruent. So that would be angle, angle, side. I also could say angle, side, angle if I use those vertical angles. So angle, angle, side is the criteria. And now I'm going to say my congruent statement. So E corresponds with M, D corresponds with N, and then C corresponds with itself. You can put the first triangle in any order you want. So I chose D, E, C. Now my second triangle, I need to pay attention. D corresponds with N, M with E, and then C with itself, so that order matters. So now in B, I see two angles. So I have the angle and the angle here, but I don't see anything else. What you want to remember is that something is always congruent to itself. So when you have a shared side like this, the geometric term for that is reflexive property when something's congruent to itself. But anytime you see a shared side, that side is equal to itself. So this one's going to be another yes because I have two angles with a side in the middle. So this is going to be angle, side, angle out of all of those options. Again, two angles, a side in between, and the other two angle pairs. Again, I can pick any order I want. So D, E, C for the first triangle. D corresponds with R, E with itself, and C with itself in this case. So R, E, C. Moving on to the next one, I see a shared side again. So I would grab that shared side and use that for one of the sides. I have the other pair here and then the angle in between. So this would be side, angle, side. And again, I'm going with D, E, C. I just picked any order. So then T and D correspond, C and E correspond, and then they correspond the other way too, obviously, with E and C. So that is side, angle, side. And the next criteria, I have two side pairs, so the 4 and the 4, the 17 and the 17, and then I have an angle pair. So I'm thinking side, angle, side, or side, side, angle. One is a yes, one is a no. Because the angle is not in between the two sides, this is not side, angle, side. This would be side, side, angle, or angle, side, side. And when you spell out angle, side, side in the abbreviation, you're swearing at yourself. So that's a no. Do not swear at yourself. It's not a criteria that works. Same thing here. I have 3 pairs of congruent angles, but I'm told nothing about the sides. So no, I cannot prove that those 2 triangles are congruent based on this information alone. So now I'm going to show you a little bit about what a proof is. We are just going to label diagrams and say how to prove this here, but I am going to show you a little bit about what the actual proof would look like. So anytime you're given information, you're going to label that in your diagram first. So notice I labeled angle BDT is congruent to angle GTD. I have segment BD is congruent to segment GT, so I'm going to label those next. And with all of these, you need 3 pieces of information. So if you only are given 2, you want to look to your picture for vertical angles or reflexive property. So the X with the angles or that shared side. In this case, DT is a shared side. So now, if it's helpful, I would cover one of the triangles up, but you're just going to look and say, okay, I have 2 sides and an angle. The angle is in between the 2 sides, so this must be side, angle, side. And here is what the proof would look like itself. You just need to be able to do this again. You need to choose that it's side, angle, side. But that is what the proof would look like. You would state your given information. You would add your 3rd piece of information. And then you would finish up with kind of like a conclusion statement. Number 2, again, I'm going to label my diagram. So angle B is congruent to angle D. AC is congruent to EC. And I'm out of information, so I'm going to look for vertical angles or the reflexive property. In this case, I have vertical angles. So now I'm going to focus. I have 2 angle pairs and a side. So this is either going to be angle, angle, side or angle, side, angle. Because the side is located not in between the 2 angles, this is going to be angle, angle, side. And again, you just need to be able to say angle, angle, side. So that's all you need. Everything else there is if we were writing proofs, and we are not going to do that this year. Given AB, so segment AB is congruent to segment AD, segment BC is congruent to segment DC, and then again I'm out of information, so I look for reflexive property, which is the shared side, or vertical angles. In this case I have a shared side, so I'm hoping this one is side, side, side pretty clearly. You have 3 pairs of congruent sides, so it should be side, side, side. And the last example here, again I'm going to label angle B congruent to angle D. We're going to do a little bit of a fast forward and show you kind of what can happen. So part 2 is when you have a vocabulary word involved. If C is the midpoint of AE, we know that those 2 pieces are congruent because a midpoint is in the middle, therefore it has 2 equal sides next to it on either side. And then I look for the picture for my last piece of information, which is vertical angles. In this picture, I have 2 angle pairs and a side. The side is not in between the 2 angles, so this would be angle, angle, side. And angle, angle, side, again, is the only piece of that you need. We are not writing the proofs this year. So that is it for part 1 of LT2. Have a great day, and I will see you in class.